Hello, everyone, and welcome to day one of the Riyadh 2023 Meta Web3 Builder Competition. My name is Kyle, and I will be hosting today's workshop. Riyadh 2023 is a prominent Web3 summit dedicated to Ethereum, designed to gather developers and builders from Riyadh, Saudi Arabia, and other Middle East regions. With a strong focus on the Ethereum ecosystem, Riyadh aims to provide insights from industry experts and engage in discussions around the blockchain future. So let's start by giving a special thanks to our community organizing committee. This includes Tharawat Technology, Studio 1727, Chain IDE, Coffee with Crypto, and Mask Network. The event schedule for Riyadh includes the online bootcamp and competition from September 18th to October 10th, the in-person reception and conference on October 10th and 11th, and the online closing mixer on October 12th. If you want the latest information and updates about Riyadh, you can follow 0xETH Riyadh on X, formerly Twitter. You can join the Riyadh Telegram group, and you can visit ethriyadh.com. I want to thank you all for joining us today to embrace the spirit of collaboration and innovation in the blockchain developer ecosystem. We hope the Riyadh Meta Web3 Builder Competition event can foster growth in the ecosystem and help developers of all levels to improve their skills. And just in case you weren't aware, there is a $30,000 prize pool. So registration is open now. Sign up if you haven't. We will be hosting daily workshops from September 23rd through September 28th, and our competition submission deadline is on October 10th. For a detailed schedule and the latest information and updates on the competition, you can visit ethriyadh.com, and you can join the official Meta Web3 Builder Competition Telegram. Before we get started, I'd like to take one more moment to thank the event sponsors, Web3 Port and Moon Capital. So without further ado, let's jump into day one. On today's schedule, we have 6 sessions. We will be joined by the following guest speakers: Wei Tsai, assistant professor at the Chinese University of Hong Kong, Shenzhen; Abdu, a senior smart contract engineer at Trust Wallet; Jeffrey Hu, the tech lead of Hashkey Capital; Kyle Peacock, senior software engineer at Dfinity; Joshua, the founder of RSS3, and Sandipan, the developer relations engineer at Shardeum. If you have any questions during today's sessions, please leave them in the live chat. For the sake of time, we won't be answering any questions during our session. Instead, we will gather the questions from the chat, and we will post the answers later on in the official Telegram group. So let's turn it over to Professor Wei Tsai for his session on Web3 Metaverse, research on communities and interactions.
Hello everyone. Today I'd like to share the thoughts and some of our research work in Web3 Metaverse. Regarding Web3 Metaverse, probably the most interesting and most important question is, are you alright now? Yeah, this year has been a roller coaster. We have all heard of the buzzwords, AIGC, superconductors, and even the aliens. But how about the Web3 Metaverse? Well, it seems it has been a long time since we heard of the news, right? Less media buzzword, and fewer investors line up, and not as many new faces join in. But we are still here today. We are consistently developing and researching Web3, or in a broader sense, so-called Web3 Metaverse. Because we believe it holds the prime as the intersection of 3 key communities: the Web3, the crowd intelligence, and the immersive convergence. In this talk, I'll explain why we see Web3 Metaverse this way and present some of our research work in its communities and user interactions. So what is Metaverse? In our ongoing work, we define it as a decentralized, closed-loop open society system that utilizes the Web3 technologies for distribution and exchange granting users increased autonomy and control over their digital assets, experiences, and relationships. Here's the breakdown. First, the Web3 community leveraged technology like blockchain, smart contract, and NFTs to enable secure and trusted distribution and exchange of digital value, which unlocks the vital social circulation in political economics. In other words, it's because of the integration of Web3 that the Web3 metaverse could be called a society system rather than just a virtual space. Correspondingly, the mission of Web3 is digital survival, which is a response to contemporary social development. Then, the crowd intelligence harness crowdsourcing and AI for content creation. It's the economics production end with a creation empower mission. And an immersive convergence, developing technology like VR and AR to create a seamless digital experience. It plays the role of consumption end with the mission of immersive presence. Without Web3, these two communities are just virtual worlds in a traditional sense. Likewise, Web3 also need to integrate with them instead of being financial speculation. Combining these three communities, the Web3 metaverse emerged as a catalyst for social progress. Let's dive deeper and explore how these communities overlap and intersect. Through the lens of social identity theory, which encompasses identity, behavior, and feel, we will uncover the essence of how the Web3 metaverse intertwines with human experience in open society. The first one is Web3 and immersive convergence area. The Web3 metaverse does not just stop giving us a sensory immersive akin to the experience in the conventional virtual spaces like Fortnite or Genshin Impact. Combining these two communities leads to an extensive, decentralized identity. With them, we have a parallel but decentralized virtual society system for deep interactions, offering us the social immersion. The second one is the Web3 and crowd intelligence area. I believe everyone in Web3 has heard of the creator economy. The overlap area is where the concept stems from. When the Web3 joins forces with crowd intelligence, everyone can be a creator, having amplified control and rightful earning from their craft. This aligns with the behavior aspect of the social identity theory. The last one is crowd intelligence and immersive convergence. Imagine a digital world where creative has no bounds and isn't stifled with centralized platform. People can produce multi-modal creation with text, images, videos, and something else. It stands on the decentralized field set by the Web3 technologies. Now think of this. You can shape your virtual realms. These fields in return guide and influence your actions. Your decentralized entity is the compass guiding your experience and the actions, with each behavior further solidifying your position in the digital society. All these intertwined elements stretch your human's journey in the Web3 metaverse. Then, let's trace the growth of the metaverse. The term metaverse developed from fiction to a worldwide industry. Each community has almost equal contributions. The insights comes from analyzing over 127 news articles from the Dow Jones Factoria spanning 1992 to 2023. The table shows each community's top 10 industries and their similar total news numbers. In the right figure, we can see that the metaverse news trajectory from 1992 to 2023. Initially, it was almost synchronous to the immersive convergence community. By 2018, the narrative began to shift. Blockchain's promise for decentralization becomes the talk of the town, representing the immerse of decentralization in Decentraland. Then, Although the public often consider Facebook's name change in Meta in 2021 as the critical indicator of the metaverse developments, it's noteworthy that the news from Web3 community consistently dominated. It could be said that the blockchain and Web3 are the core driving force behind the metaverse's rapid developments. This is consistent with our definition and framework above. On the academic side, there is also continuous attention to the metaverse. According to the Google Scholar data, publications related to metaverse began surfacing in 1992, with a market surge noted in 2021. Roughly 14,700 relevant works were published in 2022, amounting to about 33,000 over the past 3 decades. However, unlike each community joining and equally promoting metaverse industrial development, most of the top related academic research topics are still within the immersive convergence and crowd intelligence community, like virtual world and immersive environments, user parameters and communications, and AI. Top A, economics and social economic systems. Top 9, blockchain and crypto, which are directly relevant to Web3 community, still lack appropriate attention. This highlights a gap, an untapped potential in Web3 metaverse human-centric studies. Recognizing this, our lab consistently focuses on community and interaction research in Web3 metaverse. For example, Uniswap, DYDX, PairSwap, and so on. In early days, most airdrops adopt a fair allocation model, which means all project users can receive the same amount of tokens. This model introduced a challenge to the market that many fake users, so we call the airdrop hunters, create many addresses interacting with the contract in order to claim the airdrop reward. Apparently, the existence of the airdrop hunters might disturb the financial stability and centralize the governance. Therefore, some projects started to implement differential allocation schemes, in which the airdrop token amounts will be somehow proportional to the volume of their utilization. For example, DYDX sent different amount of tokens to the users based on their hitting with the ParaSwap contract. Only 20,000 of them receive airdrop tokens. So how about the performance of this threshold differential airdrop? We conduct our studies based on on-chain data analysis. The target is to examine how the airdrop receiver handles the rewards and to evaluate the effectiveness of the airdrop strategy. Also, we would like to identify the airdrop hunters' behaviors. What we are trying to do is to map the addresses transaction flow to a similarity graph, where the node will be the address and the edge weight will be the transaction similarity. We define the similarity based on the evaluation functionality. And based on that, we perform the hierarchical clustering, try to classify the users. The airdrop receivers are classified into 14 clusters. By observing the amount received, we can say that the members with proactive token purchasing behavior are statistically more likely to be involved in more permanent and sustainable financial. Established over 3,500 Twitter account Ethereum address correspondence through avatar image recognition. In the Goblin online community, we find 4 key roles under information manipulation: the project team, the KOLs, core community members, and counterfeit projects. Through network visualization and NLP analysis, we discovered that the most spreading information source were KOLs and counterfeits. Their tweets were mainly related to rumors and the fear of missing out messages. And the analysis reveals under the information manipulation, the sentiment of all discussion participants become fanatic, but return to rational later. However, The core members, like the NFT avatar users, maintain the fanatic. On the other hand, by clustering investors based on the matrix like trading frequency, profits, and trade posting volume, we identify 5 categories on NFT investor patterns. We describe them as primary investors for those low frequent trading, low returns, and low trades posted. Amateur investors, low frequency trading, low return, and high trades posted. Fanatic investors for those high frequency trading, low returns, and high trades posted. And short-term rational investors, high frequent trading, high returns, and low trades posted. And long-term rational investors, low frequency trading, high returns, and low trades posted. Notably, rational investors who made significant profit during NFT trading almost did not participate in community discussions. From a behavior finance perspective, decision-making involves allocating our attention. When an individual's limited attention is overwhelmed by a massive amount of information, it becomes difficult to make rational judgments. The high social attributes of NFTs make it hard for holders not to engage in online interactions, posing challenges for building benign Web3 NFT communities. The next topic I would like to share is one of our recent projects named Branch Clash. It's a fully on-chain game.
Branch Clash is a fully on-chain tower defense blockchain game that features a new collaboration mechanism called chain collaboration. This game mechanism requires players to engage in both co-op with other players, without an emphasis on economic incentive or modes, aiming to extend their own chain.
Different from many blockchain games, we are actually making the game fully on-chain. That means you are able to play the game through the smart contract. As you can see from the left-hand side of this figure, everything is deployed as a smart contract functionality. You don't even need an interface to connect it to the game. You can send transactions to play the game. Of course, in order to provide a better experience, we also provide a website that's developed by Unity so that you are able to enjoy the interface, so that it will be easier for you to play the game. However, all data on operations executions are fully on-chain, so we don't have to rely on the website or any centralized service to run this game. This is what it looks like when we are playing the game with Unity. Inside the tree trunk level, player can strategically place their defense tower. In contrast, inside the tree root levels, player can deploy debuffs to hinder the progress of the tree trunk players, preventing them from successfully completing the level. You are mostly welcome to visit this website to play the game. Thanks for listening. If you have any questions or comments on our work, feel free to find me on Twitter. I'll be pleased to connect to you there.
Okay, and everyone, please give a big thanks to Wei Sai for that wonderful talk. Remember, if you have any questions about any of today's sessions, please leave them in the live chat. Our team will collect them and we will be posting the answers in the official Telegram at a later time. So for our next session, we are going to be joined by Abdu, and the session topic is Mastering EVM UX, Security, and AI in Blockchain Applications. Enjoy.
Enhancing UX, security, and leveraging AI in blockchain applications is really crucial for mainstream adoption that involve all type of users. Either they are technicals or they knew about cryptocurrencies and blockchain, or this is the first time. Teaching users how to use complicated blockchain application, it proved its inefficiency for adoption. It's harder to teach people or explain them the very need specifics. What is an address? What is a private key? What is a seed phrase? In this workshop, we will delve a little bit deep into EVM, but without going too much deep due to the length of this workshop. So my name is Abdurrahman. You can call me Abdu. This is my Telegram, Twitter, and GitHub. Feel free to reach out to me. And in this workshop, we will have two parts with a small bonus. So first part is EVM logs. So how can we build a mini transaction explorer where we have transaction hash and we can see what happened during this transaction. The second part is going to be transaction simulations, which is how can we see the outcomes of a transaction before sending it to the network. At the end, we're going to see how AI can leverage and enhance or simplify the user experience for users. So, just a little bit reminder, we should never forget that at its core, blockchain is a specialized database. At the end, it's just a database. Obviously, unlike traditional databases, it uses decentralized immutable ledger, and we must emphasize on decentralized and immutable to offer a unique blend of transparency, security, and resilience, which is the origin of Web 3.0. So this is the main difference between Web 2.2. So EVM have two main states. One is the state in smart contracts on the ledger and the logs. So we're going to see the difference between both. And in this specific workshop, we're going to focus on logs more. So the state is the current state of the blockchain. And the logs are historical, which means you can get 500 blocks ago the logs easily. Obviously, you can get also the state, but logs are meant to be used historically. States store variables like account balance and contract data. Every interaction with the contract is just a change of state, and it changes over time. In contrast, logs capture and store events can't be changed once it's written. So it doesn't change over time. Once a event is emitted, then it's emitted. You can't really change it. You can emit a new event, but that's already issued. So modification to state require gas, can be expensive sometimes, especially if the state is at a zero state. And it's obviously costly, let's say, to interact with when there is network pressure or congestion. So creating logs costs less gas, and yeah, so this is the main differences between logs and state. Every developer, especially in Solidity, knows specifically when should use state and when should use logs to save user gas and make the contract more efficient. So let's delve directly on hands-on, and we're going to see how we interact with RPC nodes, get the logs, decode them, and get really important information about the transaction. It has simple configuration, and it uses mainly three packages, which is .env, EtherJS, and tsnode. So tsnode is used to run the project. .env is to get our environment variables. And EtherJS is a library. Alternatively, you can use Web3.js, and it helps you to interact with gRPC nodes and do many needed operations, like for example encoding and decoding ABI or params that are used specifically by EVM. So we have assets here, which is we have the main, we have data here. We're going to see what is it exactly later, but the main idea of this script is going to be to get the logs, decode the logs, and know the type of assets being used there or exchanged or affected by this transaction with this hash. You can use any transaction you want, and you can apply this to any transaction regardless what is it. So first of all, first thing we need is to create a provider. We're gonna use that by creating a new ETH JSON RPC provider. As you can see here, I'm gonna show you there is multiple service providers that can be used. For example, if you have Meteora, you can use Meteora. If you have Alchemy, you can use Alchemy. Here, what I'm using is just a public node, so we're gonna use JSON RPC provider. By the way, if you want to get public RPC endpoints, you can check chain list here. You can click here, you post sorting, and you can get a bunch of public nodes. So, but you need like, for example, there is node real. You can get their API also if you sign up, and you can get it free with rate limits, similar to, let's say, Meteora or Alchemy. So it's up to you which one you use. So for me, I'm just using this. So don't be limited and use whatever works for you. So I go here, I put this in my environment files. You have to do this, especially if you have something with your API key. You don't want to leak this in GitHub or anything. So we get process .env, and we got this. So we got our provider. Now within our provider, we can get a transaction, right? So transaction is equal, we're gonna go providers and say get transaction receipt, and here we're gonna just provide the transaction hash. So this isn't a promise, so we need to wait for it. It needs to reach the RPC node and get back to us with the results. So what we want to do is, like, first let's say what we got. So here, as I said, I'm using TS node to run this, and let's see how it goes. It went well, it's fine. So this is like the transaction receipt. What it's gonna contain? It's gonna contain the two, which means like transaction who's the recipient of this transaction. It's the two, the from who signed this transaction, who sent it. All other, let's say, metadata like the block number, hash, and the hash of transaction, the index, the gas, and the status and the type. Status, if it is here, we can see it's successful because it's one. Logs bloom. So we don't see here the logs, but once you go here, logs, it's going to show. So you can see here, it's like expect logs also to be null or identified, else it's an array, because there is some transactions that doesn't emit any events. And events are optional, sometimes are required for EIPs, but it's not always expected that any contract or any transaction gonna emit events. So let's run this and see what logs do we got from this transaction. So you see here that we got an array of logs. It's a set that contains only one log for this specific transaction that happened. So it tells you exactly three main data you need. So first of all is the address, which means like which smart contract did emit this event, because in more complicated transactions there are going to be a lot of contracts involved, and each contract going to emit its own events. So here you're going to see always the events tied and linked with the contract. It's not you're gonna see all the events being emitted without knowing from which address or from which contract. Then this makes sense. Then the next important part is topics. Topics is an array of 32 bytes. So the topic here in this case, it have also the first element, which is very important. The first element gonna tell us what is the event signature. So we're gonna see this in more details later, but here we wanted, say, to use more EtherJS capabilities that offer us. So let's say we are interested to know all the ERC20 events emitted by this transaction. So if you don't know about ERC20, pretty sure everyone knows about it, but if you don't, feel free, let's say, to go and read it from the EIP repo here. So we're gonna create an interface of ERC20, and it's pretty simple using ethers.js. We're gonna create here ethers.interface. We're gonna interface. I need to provide the API. So I have the API here of ERC20. This is how it looks. So I'm just gonna import it here, ERC20 API, and yeah, and then we got the ERC20. So now rather than just showing the logs like this, we want to parse them, right? So we go here and map it. So we got an event here. So what we want to do is return the event as it is, honestly, first, without messing with anything. And then what we can do is show the parsed data here, if it exists. We're going to see that. So we can get, let's say, the same, we get here the ERC20 interface, and it have a function, it have many functions that helps you interact with this kind of interfaces. And the interface is built on top of the API you provide. So whatever the API you provide, this interface will be able to handle decode or encode. So here what we want to do is like parse log, right? And parse log, what we need to pass is topic, as you see here, like in the TypeScript, topic and data, but we know that topic and data already exist in the log here in the event. So we're just gonna ignore this, we can ignore it by any, or like, yeah, let's then do it, you know. So let's go topics, and here event.topics and data, okay. So topics, what it says, read only can't be strings. Yeah, I mean, it's the same problem with this kind of backward compatibility, but yeah, it's fine. So again, what is it expecting? It's expecting strings as string, and yeah, I think the problem is only with read only. But yeah, let's see now if we run this, what's gonna happen. Yeah, by the way, parse logs, what's gonna do is either gonna be able to parse the logs, because those logs can be parsed by the API you provide, because if you don't provide the API, there's no way that ethers.js will be able to understand these logs. But because we have the API, it can parse it, but if it doesn't, it's just going to return null, and our parse is going to be null, right? So let's run this and see. You see now it's different. So this is the difference between the previous one. The previous one without parsing any logs, and now with parsing logs, we can see that we have parsed here. So parsed, what it shows what is the name of this event, which is approval, and this is the signature, you see, and this is the topic. So what is the topic and the signature? So I'm going to show you here in a second, when I said that the first element of the topic is the signature, the CUHK of the signature of an event. So let's go here in the EIP, let's go event, yeah, approval. So this is the event. It have approval, what is the name, similar to function signature, but with function signature we get 4 bytes, but here we put 32 bytes. And then it's approval, first param is type is address, and you into 5.6. If we go here and we can test this, approval signature, it's gonna be CUHK, so 2 UTF bytes. Yeah, we need it from string to bytes. Okay, so this is the approval signature here, as you see. So let's test this and see here. This is after logging our stuff. We can also log this approval signature and see if it is really the same or no. And yeah, you see it's the same here, as we said. So this is the way how ethers.js were able to know what is this event. First of all, it takes the first element of the topics array, okay, and check it with the API. So if you go to the API here, approval, you see this approval, it says it's an event. Okay, what are the types? We have address, and U into 56. So it takes it, it hash it, and to build all of this hash mapping. Then it goes through all events and compare. Okay, so it takes always the first element and see if already knows what is this. If it knows, then good, then it can parse it. Now, we go to the next part of it, which is what are those, let's say, second, third, and third elements, and what is data is used for. So, in AVM, events can be indexed. What you mean indexed? Indexed in a way that's going to exist here in a topic array, and you can query them by index, similar to any database. You just by index rather than searching all the logs. And here it makes sense that we want to know the owner and the spender to be indexed. So we don't want to go through all the logs, but if we want to get the owner only logs, we can query that directly with this owner because it's indexed and we get only the owner events, not all the events that emitted by smart contract. You can imagine big smart contracts have thousands or maybe millions of events. We don't want to get all of them. We want only the user one, right? You have the spender also indexed, but value, it is not indexed. And here, so the second element is the owner, bytes 32. What we know, it's an address, so it's 20 bytes, which means all of this is just padding. We're going to see how we can remove that. So you can see here, we're going to show args later because it's just not showing. And the second element is the spender, right? And then whatever remaining, the remaining of all params, because in this event there is only 3 params, right? But in other events maybe there is 5, 10, 6, doesn't really matter. They all going to be here ABI encoded in the data. So here it's the value. So let's go and see now the args. So what we want to show here, let's make it this, okay, and it's fine here. We're just not gonna map, but we go for each, and we're just gonna, let's say, console log this, right, and see how it goes. So here what we're gonna do, we're gonna see like when our params are parsed, what is showing. So let's go and see it again. Let's reduce the noise in the cell. You can see here, like here we are showing only the parsed, and you can see the name, signature, topic, and results. So this is the args. The first one is an address, the second is address, and the third one is U into 56, which is like the maximum. Here, like the user approved. So this is the user that approved this contract to spend maximum amount. So we want to see this easy. Let's go now and see how this is. Let's say Etherscan, let's say transaction, put this and see. You see this user, right, approved this, right, to spend. Now it's not gonna see, like it interacted with this contract, which is rapid ETH, right, and send all of this data, and we're gonna see it approved. So this user approved 1 inch to spend maximum amount, right? All the amount to be spent. Yeah, so this is an example how you can build a block explorer or like small, let's say, transaction explorer. Obviously, like the block explorer is more complicated. You can see here, like this is how also like Etherscan is doing it. It just decoding this event. It shows you, let's say, who's the source, this is the guy, who's the owner, the spender, and this is the amount. So yeah, if we want, this is like, as I said, we are using directly ERC, like here the interface from Etherscan. Let's say we want to do it manually, right? You want to go and do it by yourself. So what we're gonna do here, let's go again, map. So we have here events, and see, let's say, if we will be able to decode this by ourselves, right? So we said here we have an event. So first thing, we know that there is an approval, so we want to check all the events and capture only the approval one. How we're gonna do that is, first of all, we get, let's say, the signature of the event. This is because it's logs, and it's gonna be event topics, and it's gonna be the first, as we said. Then if, right, signature is equal, let's say, approval signature, then what we're gonna do. Then first of all, let's make it easy, right? Let's console log found an approval event, right? Pretty simple. Run it again. We found it. Found an approval event. That's cool. That means like we were able to match the function signature with this CUHK that we built. So we know this is an approval ERC20. Then what can we do is we know that the second param here and the third param are the spender and the owner. So let's make it like this. Yeah, make it less buggy. It's noisy. So we said here. So what we're gonna do is console log. This is an ERC20 approval. Come on, bro. Approval, and what we want to get is we want to get three params, like the owner, spender, and the value. So owner is the second param, right? Topics, or maybe let's do it even way. Yeah, topics. Topics 1, like this is the first param. Now the second one is okay, we can get it like this. Owner, spender, because we know it's in ERC20, and it's gonna be topics. So we ignore the first one. We got spender, but if we show them now, like console log owner is this guy, right? Spender, let's see it. Oops, owner, spender. Let's remove this buggy here, we don't want to see it. But this doesn't look like an address, right? So we need to decode it. And it's pretty easy to decode. So what can we do here is we create ABI coder, which is like also provided by EtherJS. You see here, just create a new instance, and here what can we do is like we do ABI caller.decode, and we provide here the ABI, which is going to be here address, right? And here we put like the owner, right? And we can do the same here for the spender. So we just need to send spender because we know it's like this here. Spender, let's see now, it's gonna look like an address or no. Looks like an address. So we were able to decode it from 32 bytes to an address. Now let's see the value, which is the amount. So it's gonna be similar with log, let's say value or amount, you can name it whatever you want. And here also, we didn't use it. So, and here also we're gonna use the ABI coder, ABI coder.decode here, but the difference here, the ABI is U into 56, right? And here what's gonna be is it's data, right? So the data, as we saw, the data, we got this, and to string, oops, we have an issue here, my bad, man. So this is the second param. Okay, this is the value, this is the maximum amount, and this is the maximum value. So we saw here how we can leverage directly EtherJS, or if we want to do things manually. So yeah, let's go to the next part of this workshop. So into our next topic, and it's about simulation. So what is simulation in the context of EVM, or virtual machine, Ethereum virtual machine? So it is the idea of like locally emulating a transaction execution without committing it to the blockchain. I mean, not submitting it to the network. So this allows for comprehensive analysis of the transaction outcomes when it comes to, let's say, events, cost, balance change, state change, on all of that before even broadcasting it to the network. This is going to empower users to make better choices, rational decisions, only by previewing the outcomes of every transaction. This also going to improve user trust before clicking the confirm button on each transactions, and this is going to also enhance the user experience, and the main benefit also going to be the security, right? It's reduced the risk for really, let's say, bad mistakes, phishing attacks, or spam, or anything that plays on the user unexpected knowledge about the transaction specifics. So to see that in details, you see here that I start, let's say, a swap on 1 inch, and actually this is the user what's going to see. So it's going to see, let's say, where it's been sent, the network, and if like click details, you're going to see only this hexadecimals. So how can we help user when it comes to this situation? Is we can copy all of these details here and, let's say, use a simulation provider. It can be your local simulation, or here in my case I'm using Node-REAL. There is also Tenderly and Alchemy that offer this feature of simulating transaction. So you can see here that we are using debug tracer call with like a custom tracer called tracer. This is all here like specified in the Git. So you can see here and see the params you can send. So this is the built-in tracers, and this is the one that we are using now, the call tracer, and it's going to return a bunch of details that we're going to see here. So what we need to send is the params of the transaction, from where, who's like signing this transaction, the to address, here in this case is 1 inch, and the value, here we're not sending any native, and this is the data, the hexadecimal one, and this is the one here that we copied from the hexadecimal value. So here we are telling the simulator to run this on the latest block, the latest state of the network. There is multiple states status that you can check, and here we're using the latest. Here we're just specifying which debugger we're using. We are using a tracer, and we are asking to return the logs. As you can see here, this is going to be the result. The result is going to have our initial data here and all the calls associated with the transactions. Calls are internal calls. Some of them are normal calls, some of them are delegate calls, and some of them are static calls. So you see here it's an array of calls, and each call have completely new set of variables or parameters to call something else. And each one of them have more calls, more nested calls, and some of them, you see this is static call, some of them have logs. So this is similar to what we saw in the first part of this workshop. You see here other as topics and data. This is something similar to the same we saw. As I said before, topics gonna always have the first element which will signify the event signature. You can see here like a bunch of logs, nested ones. Some of them are the outer context, some of them are like really nested inside. So you can imagine now that we can use our knowledge and try to understand all of those logs and extract the ERC20, ERC721, and the native ETH, let's say, transfers, so we can build this mapping of the assets transfers from where assets are moving to where, and then we can provide user with more insights about actually what really matters to the user, what's leaving his own wallet and what's getting back. This is something we already started working on. We have an SDK here. It's called Wizard SDK. It helps, let's say, to do all of this, let's say, decoding and abstracting the user assets. Or you can submit any merge request here if you have better ideas or you have something else you are working on. Please do. This is a public community-based package, and we are happy really like to help if you want any need, if you need any help, or if you have ideas and features to include also. So you can see here like we have separately, like here the simulator, for example, we have providers, Node Real. Obviously you can add your own provider here, Alchemy or Tenderly, and you can see here we have a bunch of functions that's going to help decoding all of this data. Here you see this is processing the data and so on. So yeah, going back, so this is the Wizard SDK. You provide, let's say, call data, and then the SDK gonna try, let's say, to return some outputs that's readable by computer, but can be represented very well on the UI or on any level, or even if you do this analysis privately for your own, let's say, a project or something, we believe this is going to be beneficial. So Trust Wallet also, we're working on this, on changing our preview to the user rather than showing these hexadecimals values. We want always to show like a better UI, user experience, and security analysis on top of that. So now jumping like how we can leverage AI into this. So because we can go to like simulate transaction and abstract the user assets movements, we can end up with something like this when there is assets in and assets out, and all we need to do is like this example I'm using ChatGPT for, or you can use Dfinity or whatsoever, and you just give him some context that this is like this is related to transactions on the blockchain, and you want, let's say, to highlight the user, right? The user, let's say, effect on this, what's affecting the user wallet here. And you see here that it's doing a good job already. So here he's analyzing, let's say, this, that USDC, ETH amount in USDC, you can get the prices of NFTs and assets very easily, right? And here it telling you like this looks like a good transaction. You are making, let's say, benefits of $800, but here this is user minting a new NFT, and you see like how beautiful it provides more context. It's saying that like without knowing the market value of the newly minted NFTs, it's uncertain whether you are made a gain or incurred a loss. So exercise with caution and make sure that you are interacting with the legitimate NFT collection, for example. You see here is like it's more like user is sending ETH 0.5 is even nothing, so we're like telling them like straightforward that this is like extreme caution because this is most probably just a scam. And you can see here that user, like even like if there is user sending 0.5 ETH but receiving only $1 when like he should receive 1,000, it makes like there is very, let's say, spread or slippage there, you know. So thank you so much. The last part, that was the last part. If you have any questions, again, reach out to me. You can find the presentation here and the SDK and documentation about it again. Thank you so much.
All right. Thank you so much, Abdu. Everybody, let's give him a big thanks in the chat. And just a reminder again, if you have any questions for Abdu, please leave them in the chat. The team will pass them along and we'll put the answers into the official Telegram at a later date. So let's keep moving forward and we'll move on to our next session with Jeffrey Hu. This session is titled Hashkey Capital Interoperability Overview. Thank you.
Hello, everyone. I'm Jeffrey Hu, tech lead of Hashkey Capital. Today, very happy to have this chance to share some of my overview of interoperabilities. So maybe first thing first is allow me to introduce about Hashkey Capital. So Hashkey Capital is currently is one of the largest crypto fund because our current AUM is over $1 billion US, and we have invested more than 500 investments, including infrastructures, tools, and applications since 2015. And we are also one of the earliest institutional investors of the Ethereum back into that very early times. And Hashkey Capital is also continues to actively investing many new projects right now. And so with our country research and also talking with very talented founders of the projects. So we also have this kind of maybe some novel knowledge about the industry. So today we are also very happy to share some of our maybe insights of the industry. And about me, I'm the tech lead of Hashkey Capitals, and I myself in charge of all the technical things, including tech DD and also technical research of the Hashkey Capitals. I myself is also Cosmos Chinese community ambassadors, and also sharing some maybe knowledge and insights for the Cosmos Chinese communities. And I myself also wrote several blockchain technical books and drafted several blockchain standards. Very luckily, they are also interoperability attribute standards. So, so that's maybe a brief introduction about myself. So for today's topic, I want to share you with some of my maybe the overviews and also knowledge of the interoperabilities, including the interoperability classifications and also maybe some new trends we see in the industry right now about the interoperabilities. So as we also actually quite actively monitoring all the progress in the industry. So actually, if you followed me on Twitter before, actually I made some prediction about interoperabilities last year, almost the same time of this year. So I made several maybe predictions about the cross-chain trends, including the bridge or maybe cross-chain technicals should be more lightweighted, and we could use maybe Oracle's TE and ZK to have this bridge to be built in the futures. And second one is that a bridge actually is not only for end users to transfer tokens or swap tokens. Actually, it could be also used for developers that can to provide a better developer supportings, like providing some SDK or some kind of the smart contract invokings. So that may be the second one. And third one is that we can maybe foresee some novel liquidity designs, like maybe cross-chain swap, token swap, or maybe this kind of the AMM between the different chains. So that is maybe, so we can call it as interchain or cross-chain swap in the futures, as we see in this industry right now. And lastly, interoperabilities is not only something that could be only built upon the particles. Actually, it itself can maybe have some affection back into the particle itself, back into maybe the consensus, also the network itself. As we can see from last year, there's a lot of solutions and designs for the shared securities that are coming out. And also there'll be some of the particle designs, including the MEV and this kind of particle designs could also be bought by the interoperabilities. So that's maybe some things I have done last year. So what kind of things I made are right or wrong or missing from the predictions? So I also made a summary of these predictions I made. If we see from this year's, maybe let's start from the first one is that Oracle's, I think, should be right, because we see there's a lot of the Oracle solutions are providing interoperabilities as they are maybe one of very important usage, including Chainlink, Supra, and also some other Oracles. They are providing this kind of interoperability solutions right now. I will also cover the reason why the Oracles will be very focused on this area. And for the TE, actually, I think maybe not so correct, because we don't see lots of the solutions, including the TE right now. Although it's also TE is still quite useful in the industry for the MEV or maybe some privacy solutions or maybe some other scalability solutions. But we don't see TE is still quite widely adopted in the industry. Maybe you can see in the futures. But for the ZK, I think I'm right, because there right now there are lots of the ZK bridges to building upon the are built for the questions. Although their designs may be different, but they are also quite focused on this area in wide definitions. So another thing is about dev support. I think we can also see lots of the SDKs are supporting this kind of the dev support right now. And for this maybe fifth one, we can see the interchain liquidities. Not only maybe the AMM or maybe some token transfer right now. We can see lots of the new interchain or maybe unified liquidity design right now in the industries. There are also some very interesting design for maybe the trading or maybe something else that could be we can see on the application layer. And also for the last one is about the particle design. We can see for this year there's interchain security launched in Cosmos, and there are maybe mesh securities coming also on the Osmosis and other network. So that's another thing quite interesting in the industry. And we also see the risk staking on the Ethereum and other network right now, which is also we can also see they share some similar ideas and designs of the interchain security. And for the interchain MEV, we can also see, actually we also see the Flashbot swap that can support this kind of interchain MEV, and also maybe some other protocol like maybe skip protocols in Cosmos could also support this kind of interchain or multi-chain MEV. So that's also maybe some predictions I have made for last year. And what I missed maybe should be the stablecoins bridge, because we can see Circle and other stablecoin are building their own bridges right now, which is quite useful and also very handy for the users. So that's maybe something I missed in the last year, but we see that is quite excited also for the user and also for the bridge itself. So here I want to go back to the maybe definition first, and after that we can jump into the trends we can see in the futures, because we need to know what is interoperability first, because everyone may have their own definitions about it from their own opinions. But in my opinion, that interoperability actually is an interaction between the Web3 infras, because we can see there's a lot of different kinds of infras on different layers of the Web3 industry right now, from maybe the particle layers to the infrastructure layers to the developer tools, all the way up to the application layers. So that's something we can see. There's a lot of different heterogeneous design and architectures for the Web3 infras. So how we can make the data and also the users could interactions with different layers and different particles within Web3. I think that's maybe not a very easy problems that could be solved. So we need this kind of interoperability design solutions. So we can see there's a lot of bridges to be built to actually try to solve this problem. But how to classify them? Because someone may argue that we can classify by maybe the bridge, whether it can be support one token or maybe support multi-token, whether the bridge can support only the token swap or token transfer, or they can support arbitrary message passing, or maybe they can support only one network or maybe two networks to multi-networks. So we can see there's a lot of the classification methods that could be used for bridges. But in my opinion, if we want to classify the bridges, we need to something new that we can have a better idea and better views on the bridges. So one of the takeaways from today is that I recommend you to analyze the interoperabilities from this perspective, actually we can borrow the ideas from the IBC particles in Cosmos, because IBC particle just classifies all the particles into two levels. One is on the communication levels that is basically in charge of how the message could be passed between chains and verified on another chain. So that is the communication layer. And for the application layer, so that is only we can just focus on what kind of applications could be built upon the message that passed between the chains. Like we can maybe support the token transfer, or maybe we can also support the swap, and also maybe maybe something like liquidities could be built upon the application layer. So with this kind of the perspective, maybe we can have a better understanding of the bridge or maybe the cross-chain technology. And yeah, so what kind of problems could be solved by the interoperabilities from that perspective? So actually, there's also some maybe ideas that I can share with you is that if we take a step back to look at the blockchain itself, so blockchain actually solve the trust problem that within one chain. So for the interoperabilities or maybe cross-chain, actually it solve the trust problem between the chains. So that is, so if there's a message be passed from one chain to another, actually the message need to pass is one is the transaction itself, and the second one is the proof that can prove that transaction did happen on another chain and be confirmed on the that source chain. So that's maybe the essential things and essential informations which we need to be handled for the interoperabilities. So with this kind of the view and also the classifications views, we can also actually to deepen into the different layers, and we can have a better understanding about the interoperability, and we can classify the bridge very well. And first thing we can see is a communication layer, so that we can just to how to verify and pass the information, verify the information that passed from one chain to another's. So we can see there's maybe several different ways to classify it. Is one is for the external verify. So that is also something we can see lots of the bridges are using this kind of way, because the cross message should be passed and verified by some third parties. Like maybe they can pass it through the multi-sig or maybe just so-called gateways to pass the information and verify the cross message. So, but for the users, they have to trust the third parties to do some evil things to hack or maybe modify some message or maybe some things that they don't want to have. But the advantage of this kind of method is that this kind of external verify could be quite easily and quite quickly to connect with different chains, that even also for some heterogeneous chains, as long as you can handle the address and the message passing and these kind of things, that chains could be connected and could be cross-chain bridge. So that's for the external verify. And for locally verified is something that user can observe the on-chain events by themselves locally. So that because we can see user can themselves actually can get all the informations from all the different chains, and they can trust themselves about the observations. And for users how to interact with other users that they are also observed on the chains, actually they can use some method like HTLCs to interact with each other, so that they could not cheat with each other about the token swap. So that is locally verified. And a third one should be maybe natively verified. So actually it's also comes from my naive ideas about the cross-chain. So when two blockchains need to interactive, actually the one of the easiest way is that they just need to integrate each other's particle within their own particle. So that could solve the problems. But actually, it's not a trivial thing to do that. Like maybe their code will be integrated with each other and they will handle all the message passing within each other. So it's not something quite easily to be built, especially when the blockchains has launched their mainnet. That's not so easy to upgrade their protocol. So another way is to maybe take a step back and to integrate with the light clients that could verify the information to be to be passed from another chain, that we can just maybe verify the transaction cross-chain bridge with against the headers of another blockchain, so that I can so that the one chain could be trusted that information actually did happen on the another chain and could be confirmed on another chain. So that's native verified. And usually that could be done by the light clients I just mentioned. But we can also see maybe there will be something new that we can also maybe enable some maybe similar full node effects by the help of a ZK bridge, this kind of knowledge I've covered in the next slides. Okay, so that is a communication layer. On the application layer, actually, we can also see there's just maybe some trading method between the different chains. So we can also borrow from the idea of how we can trade assets between each other. So one of the very simplest way is that there's a centralized counterparty that we can just trade with him to be swap in and swap out tokens. So that is also often adopted by some tokens so-called official bridges that you can just swap in and swap out with their official addresses, so that you can have your tokens to be bridged. So that's a centralized counterparty method. Another way is that there's actually is no need to be centralized counterparty. We can also do it by the OTC or P2P ways, so that counterparty is a market maker or maybe some other users, so that you can, when a user wants to swap a token on the net, on like let's say maybe chain A on the different users on chain B, actually they can just to swap their token with each other through OTC way to have this kind of tokens on a different way to be swapped. So that's an OTC or P2P way. And for the third one is the swap. Actually, the counterparty should be protocol or AMM swap pools, so that user can swap in tools, just like maybe we can see in Uniswap and other AMM swaps. So that's a user just swap the tokens. We call it intents. For this area, we can also see there's a lot of cross-chain MEV and also intents in this area. And the third one is the stable coins bridges, which is also quite usable and also very large sectors of the applications. So that's maybe the whole overview of this year about some new methods and also technicals to have this different chains to be connected. So this table is something I also borrowed from the Delphi Digital, and I upgraded with some very latest upgrade of all the different projects. As you can see now, there's lots of different projects are building, like Polyhedra, Electron, Polymer, 16, and Neo Foundation. They are also using different technicals to connecting with different chains. So that is ZK Bridge. And next one is for the liquidities, because we see applications is also very useful in the works, like maybe the MEV. We can see the Flashbots are building Swap, and also some similar projects like Essential are building some MEV solutions right now. And also the intents could also be helpful for the cross-chain swap, like maybe in the futures, user just want to have their tokens be transferred or swapped from one chain to another. Actually, user just don't care about which bridge or which protocols they want to use. They just have this kind of intents. So intents, the protocol can maybe help in this kind of areas to have maybe better routing, a better liquidity, and lower slippage during the swap. So that says also the intents could be solved in the multi-chain or maybe cross-chain area. And the next one should be the stable coin bridges. As we can see, there's a lot of, there are more and more this kind of solution or bridges right now in the application area. So so we can see for the stable coin bridges, which is quite useful and also quite I think more secure than maybe previous bridges, because they use another ways to transfer tokens instead of the lock and mint method. The stable coins bridges can just simply use the burn and mint mechanism, because all tokens actually is issued by one party, so that we can maybe for like maybe Circle, they can just count all the tokens on different chains, just like let them issued and burned and mint on another chains, so they can have less secure concerns than some very large token locked on one chain. And another advantage of the stablecoin bridges is that all the tokens actually they can be quite fungible within one chain, because right now if you see some tokens like maybe USDT or some other tokens from different bridges be cross-chain transferred, so actually this kind of token is different on one chain, so that also have some fragmented problems within that chain. But for the stablecoin itself, actually, if it is passed by the official stablecoin bridges to another chain, actually it is fungible within that one chain, so the liquidity should be more efficient. And the third one of the list of advantage of the stablecoin bridges is that because the token value is packed and stabled, so that is no or maybe lower slippage when users to transfer or swap for the tokens. So as we see right now, there's a lot of stable coins bridges are building right now, like from the Makers Teleport, Circle's CTTP, and also the GPY tokens by the Toki particles. And maybe the last one is for the crypto primitives and also schemas itself. We can also it is also something we can expect in the future, is that we can see there's lots of the MPC and TE and other solutions that can help the lock and mint scheme in the from the external verified solutions. So from the MPC solutions, we can see also there will be some more robust schemes and also protocols to building this kind of the message passing to have this more decentralized and also more secured this kind of external verified protocols. And there's also some new signatures that could be helpful for the token bridges. As we can see, there have been some Schnorr threshold signature like Frost and Roast. This kind of protocols could be used for this kind of multi-sig signatures, and some protocols are also be building using this kind of signatures to like maybe bridge the bitcoins from the Bitcoin network to another network using the Frost and Roast. So that's also something quite new in the future, and we can definitely expect that. And lastly is my 2 cents on the interoperability thesis, is that interoperability, actually, you can see that is a lagging sector after the layer 1 or layer 2 and app chains. So after we see there's so many solutions and so many projects building right now, but if we do expect there will be lots of the app chains or maybe layer 2 or even layer 3 that are building within the like maybe Ethereum or Cosmos ecosystem right now. So we can see definitely there's a lot of the demands and requirements for the bridges for cross-chain transfer the tokens and to cross-chain to borrow the liquidities on different chains between the layer 2 and the layer 3s. So that's something we can definitely be looking into that. Although lots of noises, lots of the kind of industry's attention to be brought to the modular and this kind of roll up on maybe layer 2 ecosystem. But interoperability should have maybe another maybe many more demands in the future after the booming of the rollups. And for the application layers, so my 2 cents on that is that maybe you can, if you are want to building something new on that sectors, so I recommend definitely can look into some combination with some AA or MEV or intense solutions that is quite useful for the end users. So maybe if you are also want to building bridges for some use cases, some use cases could also, you can have an eye on, should be like maybe layer 1 between layer 1 and layer 2s, or maybe some layer 1 between the DAs, like maybe Celestia, between Celestia and Ethereum, and also some projects that could also bridge it from the CeFi with DeFi, and also like maybe building the bridges between the some CEX and the bank within the between the centralized system and also blockchain system to have this liquidity be shared. So that's also something that we can maybe you can consider to build in the future. Okay, so that's it. So that's something we can we have been done in the past about the interoperabilities, and hope you have some learned something today about the interoperabilities. If you have any questions or maybe any things you want to discuss, please feel free through the email or maybe Twitters, so that we can definitely have a discussion on that. And thank you very much.
All right, let's all give Jeffrey a big thanks. And just again, if you have any questions for him on interoperability, please leave those in the live chat and we will post the answers in the Telegram group at a later date. I hope you are all enjoying this workshop so far. If you are, it would be great if you can give us a follow on Twitter for @0xETHRiyadh, and share it with some friends who you think might find this interesting. Let's keep this moving. Our next session is with Kyle Peacock, and its title is Coding with Kyle, Dfinity Software Engineer, Episode 1, Hello World.
Welcome back to Coding with Kyle. This is episode 1 of the IC Avatar developer series, and we're going to show you how to set up your developer environment. Here we are with the Dfinity Developer Center. Links for this page and any other sites I visit will be down in the description or in the page below. We're going to get started with the 5-minute quick start guide here at sdk.dfinity.org. For this demonstration, I will be using macOS. However, we do support Linux and recommend Ubuntu 20, as well as Windows Subsystem 2 for Linux. The first thing that we will do is download the SDK by copying this command and running it in a terminal. Now, with DFX installed, I'm going to move into a tutorials directory and move on to the next step. Now, with DFX installed, I will run dfx new hello. This is dfx, the name of the SDK, with a command of new, and hello as the name of the new project that we're going to create. And we can change directory into hello and take a look at what we have. Here we're set up with a project that has a main.mo Motoko file and a hello assets directory with assets and source. We'll get into what is in all of these files in later videos. For the purposes of this series, I will be working out of Visual Studio Code, and I suggest you do too, just for simplicity's sake. Now that we have our project, we can start a local version of the Internet Computer with dfx, the command start, and background will have it run in the background. Now we can verify that our packages are installed. And deploy our project to the local replica. One thing to note is that you will need Node.js installed, as it says down here. Now, your canister should be up and running, so we can test this out by copying this command and calling our canister with hello should greet everyone. That is a direct call to the backend canister. And let's conclude by spinning up the front-end canister for local development. And calling this with everyone as well. And that's all it takes to get started working with DFX on your first Internet Computer application. In the next episode, we will go over how to configure our IC avatar application and to set up the backend with some simple create, read, update, and destroy functionality. I'll see you next time. Welcome back to Coding with Kyle. This is episode 2 of the IC Avatar Developer Series. In this episode, we'll show you how to set up a basic Motoko canister with create, read, update, and delete functionality for a resource of profiles. Let's jump right into building our application in the Motoko playground. We'll start by declaring an actor. And now we'll need to define our data model. Our main thing that we'll be storing will be profiles. And so let's start by adding some biographical information by declaring a type of bio. And then we'll have a number of fields that the user can enter, such as given name, as an optional value of text. I'm using given name as the HTML autocomplete attribute uses given name and family name for things like first name and last name. So I'll be following that spec here. This biographical information will go as one attribute of our profile. And that's enough to get us started. Now let's look at how we're going to persist our information. So we want to have data that can persist across updates to our canister. So Motoko provides a stable interface. Only certain types can be stable, but we're going to use one here. A stable variable, which we're going to be able to rewrite when we need to. Profiles. And this is going to be of a type try. Which we need to import from the base library. So the try here is functioning essentially as a key value map. And we're going to be able to store values here with nats as the key, and profile as the type that we're storing. We'll initialize that with try.empty. And for that nat, we're just going to use a simple incrementing ID for this stage of the application. So that'll be another stable var, next, of type nat, and we'll start with 1 as a simple positive integer. Now let's code the functions that are part of our application's interface. To create a profile, we'll declare a public function named create, which accepts an argument of a profile of type profile. And this will return an async Boolean value. If we return true, that means that the task was successful, and false if we failed. Next, we'll use our stable var next to create a profile ID, which we can then use as our key in the try. We'll return true as our base case, just so we get a Boolean result. So now we've got our profile ID, which for the very first instance will be 1. We can then increment next. Now we will declare our interface to insert into our try. So the method that we'll be using is try.put, which has 4 arguments and will return a tuple of the new profiles, so the resulting try from this operation, and existing, which will be the value at the key which we're about to specify down below. So argument 1 is profiles, which is the try that we are going to modify. And now we need to specify a key that we want to insert our profile at. To get this key, I'll declare a private function which accepts an argument of type nat, and it's going to return a try dot key of type nat. So what this will return is return key is equal to x, and the key type here needs a hash of type hash or nat32. So what we're going to do is use hash dot hash of x for our nat, and we will need to take that hash and import that at the top of our file. So with this key method, we can come back to our create here. So we are going to insert at our tree with a key of our profile ID. And now the third argument is looking for an equality checker. So we will use the one that's provided by nat. And this will use when the key is doing like its find function, this will assess the equality. And now we've previously been referencing nat because it's a built-in type, but now that we're using a property of it, we need to import that as well. And then our final value is going to be the profile that we want to insert, which we'll get from our argument up above. And now for some additional safety, we're going to go ahead and check to see whether there is an existing entry, in which case we don't want to do our create process. We'll do this with a switch statement. So here, if there are no matches, which can be case null, if existing is null, then we will we'll rewrite profiles to equal our new profiles with the inserted profile. And in the case where there is an existing profile, we will do case of optional value, which simply signifies that there is some value there. We will return false because we do not want to create a new profile that matches an existing one. And that's all it takes for us to create our profile. The next method of our interface will be reading a profile. Here we have another public function of read, which takes a profile ID as an argument, and it will yield an optional profile. This means if we find a profile, we will return it. Otherwise, we will return null. Here we can use the try.find which will take 3 arguments. Our try of profiles, a key of our profile ID, and our equality checker. Because the result of this operation is already an optional profile, we can simply return our result. The next function that we will go through is updating our profile. Public func update, which accepts a profile ID and a profile which will overwrite the profile at that ID. Like create, this will return an async bool. We can reuse our finding logic. And now we can do a switch statement based on the result here, which will be an optional profile. It's either a profile or it's null. So if there is no profile, then we will not allow an update to be written. But if there is one, and if we have found a profile, we will then overwrite profiles to the result of try.replace where we have profiles, our key, nat equal, and the profile that we want to overwrite. And since replace is going to return a tuple just like put does, we will then take the first of those, which is the replaced try, and use that to overwrite profiles. And in replace, the final argument is an option. So what is happening here is that the try will take profiles, look up a key for our profile ID, use this equality checker, and it'll write our profile to it. Then the result of that is a tuple of the new profiles and any existing at that entry, and we take the new profiles and overwrite it to profiles. So that updates our stable memory, and then since we're successful, we return true. For delete, we can take almost exactly the same information, rename it to delete, and here, when we replace, all we need to do is replace it with null. And just like that, we have full CRUD functionality for our application. Let's see what this looks like in Candid UI. Let's create a simple one here. I'll name this Hello World. We get back true with our response. We can now read that information by calling a profile ID of 1. There's our response. We can update profile 1 and have the name be test. We get a true response. We can even verify that with read. Opt test right there. And finally, we can delete profile 1. Which reminds me, since delete, we don't care about replacing the profile, we can remove that argument. All we need is a profile ID. So we've now deleted, and we can check again. And just like that, profile 1 is now null. So to summarize, we defined our actor. We created a set of type information as well as an interface to access our actor. And we gave it create, read, update, and delete functionality. For the next episode, we'll look into how we can upgrade this so that right now, currently, anyone can access any of the profiles. They can make modifications to them. That's not going to be useful for a larger scaled database. So I'll show how to use authentication so that each user can only interact with their own profile. We'll also look into upgrading the result types so that we don't have to rely on a Boolean true or false, and we can pass some more useful information like error messages along with that. That's it for episode 2. I look forward to seeing you next time. Welcome back to Coding with Kyle. In today's episode, we will refactor our application and add better error handling using the result type to have a more informative response from our application. Let's get started refactoring our code. We're going to be using the result type, which comes from the base library, and it's going to return a variant. A variant is a type, like our bio and profile here, except that a variant, each attribute will be tagged with a hash, such as not found, or already exists, that we can use to have an expressive way of indicating, for in this case, an error message. Unlike normal types, only one type of a variant is expected. So we can use a variant here, where previously we'd been returning bool. We can instead return a result, which then expects two types for OK and error. For the OK type, we'll use this common pattern, which is called the unit type. It's an empty tuple. It's also a commonly used simple OK in Rust as well. And for an error, we'll expect a type of error, one of the variants we just declared above. This error type will allow us to say, instead of simply something was wrong, which we could also get by throwing an error or trapping, instead we can nicely handle it with an expressive error. So here, instead of return false, we return an error tag of ERR, and then the variant of the error that we want to relay. In this case, we couldn't create one because it already exists. And for the success case, we can return OK with our unit type. Now for read, we are returning an optional profile. This is an OK type, and it is considered a good pattern. I will be refactoring it, however, in order that all of our methods return a result so that we have some consistency in our API. But I do want to emphasize it is okay to return an optional value. So here we can use a nice utility. This is optional at this point, but we can return result.from an option, which if you pass it an option, it will return that result if true. Otherwise, it will return the second parameter we pass of an error. And so we can type that by saying we return result.result with a profile as the success case and an error otherwise. So now we can return the same result type as we used in create for our update and delete methods. We're returning an error not found if we couldn't find one to update, otherwise returning the OK variant. And then same thing below. And that completes our refactor. Let's see what it looks like now that we execute it. So here, a success response for create gives us a variant of OK. And when we read that information, we get a variant of OK, and then a record of the profile. However, if we read a profile that does not exist, we get this nice error message that explicitly tells us that it was not found. Now, with this refactor, we're all set up to go into the next episode where we add authentication, and now we can handle different types of error states based on authentication or resources depending on what goes wrong. I'll see you next time.
Okay, a big thank you to Kyle and Dfinity for that code along. Let's keep moving forward. Our next speaker is Joshua, the founder of RSS3. The topic of this session is RSS3 bridges Web3 to AI, search feed, and beyond.
Hi, everyone from East Riyadh. It's Henry from IS3. Today I'm going to go through the following agenda with you guys. Firstly, I'm going to introduce what RS3 is. Secondly, I'm going to show you how to use RS3 API by going through some of the documentations. Lastly, we're going to build a friend tag transaction viewer together using the APIs we've just learned. So without further ado, let's get started. So what is RS3? RS3 is actually an information dissemination protocol designed to achieve open, efficient, and secure flow of information on the open web. So what does that mean? It means we index data from multiple networks, including blockchains and decentralized networks such as Forecaster, and we aggregate everything into one simple to use API. Now let's look into the documentations. RS3 has a list of really simple to use APIs. Today we are going to be looking at data API together. So what does data API do? Let's go into the API playground. So what the data API does is it takes in an address such as vitalik.eth and it returns all the actions and activities performed by Vitalik on different blockchains and decentralized networks. So it looks like he's quite active on this social media platform called Forecaster. And if we are trying to get his activities on other platforms, such as Uniswap, it turns out he has made 19 swaps on Uniswap. So there are many filtering conditions which allows you to customize your data access strategy to build the applications you want. Today, I'm going to show you how to build a friend tag transaction viewer using RS3 API. So it is really simple. Instead of Uniswap, we'll be looking at friend.tag. It looks like Vitalik has not performed any actions on friend.tag. Let's enter an address that I know. Readem. So this address has 30 activities on friend tag. I will be using this address as the example throughout today's demo. Now let's go to VS Code. So first, let's use Vite to create our toolings. And let's call today's project is Riyadh. And for language, let's choose React and TypeScript. So now let's install the dependencies. And it should be done. Okay. So that's a basic project we have just created. Let's go into the project. Now let's install this thing called Tailwind CSS, which is going to be really helpful when we are trying to polish our UI. So to install that, if I remember that correctly, sorry. Should be Tailwind CSS and fixer. Let's hope that's right. Okay, looks like it's right. So next we're going to here we are. We're going to initialize a config file, and in the config file we're going to include an index.html file, which is right over here. And we are going to include, TypeScript. We're going to include all the files here. This is to make sure that the CSS are being applied to those files. And I think I'm missing one step. Probably I need to, let's check documentations. Oh, here we are. We need to add those derivatives here. And let's remove everything here. And yeah, I'm not going to use this one. So let's get rid of that. And now the page should look really ugly if you def. So now let's delete those two logos. And I have prepared 4 assets, image files. Let's copy them over, delete that one, and let's start. Class name is not needed. Let's make sure the source file is rs3.cg. And oh, that's big. And then I'm gonna leave this blank, and let's remove that one as well. I'm gonna call this friend hack, which is friend.png. And lastly, I'm gonna add logo for Riyadh, which is svg, and let's call it Riyadh. Okay. Next, I'm gonna modify the index.html file to make sure the title looks correct. Let's also make sure it has the correct Tailwind CSS classes. So I'm going to use flags, center, and probably some width restrictions and height as well. Oh, I think I got it wrong. It should be placed here. And for the root, which is going to be loaded from here. Okay, Miss Body, right? That's correct. So it loads everything in app and render it with this template here. So I'm gonna give this one some class as well. Maybe some auto margin, and let's center the text. Okay. Now let's go back to app. Let's remove this bit as well. We don't need that. We don't need that. And we don't need that. And not you as well. Next, we are going to add a search bar to this page. So now I'm gonna just declare a search bar here. One thing to note is declaring a new component here is actually not the best practice, but for the sake of this demo, I'm just gonna do it here. So what does this search bar do? It should return a search bar. Okay. as simple as that. So now let's render this search bar here. So we have our search bar and the search button. So let's add some style to it. Again, input. Oh, let's change the style of this input first. So first, let's make sure it has a rounded border. And let's add some color to the border. So our theme color is F. And let's also add some padding. Padding Y, padding X. And let's increase the width. And similarly, we are going to add some style to the button as well. Let's copy this one. And let's remove the border. And probably use background color instead. Okay, and we need text white. And remove the paddings. I'll probably just keep it. Now let's make sure it is a flex row. And let's place the item center. And justify center. Add some gaps to it. So we have a very basic search bar here. Next, let's add some functionality to this search bar. So we are going to be add something called on search, which is going to take in an object of query as string, and let's return void. And we are going to use the state to save the query entered by the user. So, and what triggers set query? Probably here. On click, we can trigger the action on search. And this is the query from the user. And similarly, when we have, we need a value here. Sorry. Yes. And yes. So that essentially means when the value of this input changes, it's being saved into the state called using set query. Next, we are going to use on key up. So when the user hit the key enter, we are going to trigger the search function. Next, let's modify the placeholder. Let's say search any 0x address, in as name, or Web3 domain name. Okay, now we have this completed. So whenever user clicks the search or hit enter, the query is being sent to this onSearch function. And now let's write the function that's going to be passed into as onSearch function. So let's write a function called get data from IS3, and let's use async. Okay, let's not use the autocompletion here. So the method takes in a string parameter called query. So if let's check if the query is empty. So if the query is empty, we simply just return, don't do anything. And otherwise, let's declare another use state called data. Yeah, we can use the name, or maybe use the name result. So if the query is empty, just finish this method directly. Otherwise, let's clear the previous result. Oh, sorry. It should be... Okay, let's leave it as an empty array first. So if the query is not empty, clear the previous result, if any. And now let's write the actual query. If we're going to define the platform as friend.tag, and we are going to send a query to this endpoint, and platform is platform. Okay, so what this means is we are going to use the user input as the address to search, and we are going to limit our search to this friend tag platform only. So let's see what that return. So let's see what that URL gives us. So here we have a sample result with one result. I purposely set the limit to 1 so we can have a clear view. So let's copy this result and create a new file called model.tsx, and here I'm going to use an extension which converts JSON structure into TypeScript interface. JSON, okay. So it generates all the interfaces I'm going to use. Let's call this API response. And yes, let's export interface. And for here, let's change the structure here to API response. Or it can be undefined. Oh, sorry. It should be this. And it can be undefined. So it uses the model we have just defined here. So we have total cursor result. So now let's make the API request. Here I'm going to use try catch. And let's auto generate those, and we have a finally block. So what it does is it sends out the request and it converts the result into a JSON structure, and it saves into this state, which is holding an API response, a structure like this. So if that works, we should be having the result that looks like this. Otherwise, we will catch the error. And finally, let's print a message that so this line clears the previous results saved in the state. Now let's pass this function or method into the search bar. Did I? Yes, I defined on search. So on search, it triggers this method. But yeah, let's change that back to data. So set data. So let's not call you response. And let's use data here. So we know in the data object, it is holding an API response. That's stuff images, and due to server limitations, Twitter's server limitation, because essentially this picture is being taken from Twitter. And let's write
you and me, and like it can be anywhere from the world. Then we have an RPC. An RPC is just a URL link which connects you, which lets you submit your transactions to the network and interact with anything that is on chain. And then here we have a collection of nodes. Nodes are basically individual endpoints which help computing your transactions and making sure that everything is going on the way. So the validator nodes validates all the transactions, making sure that everything is, the rules are followed without any need of any intermediary. And then finally, like your transaction gets confirmed and like you can move forward with that. So this is generally a basic overview of how a blockchain works. Is again like a very scrapped away overview of how a blockchain works. Definitely there are a lot of moving parts into this, but yeah, we can explain this in this way initially. So let's talk about the evolution of web. I think we are all aware that like we are right now talking about specifically about Web 3.0, but it all started with Web 1.0 when we had HTML, Java and JavaScript, and then basic web pages, and then e-commerce just getting started, like not even the kind of e-commerce which we are seeing right now. And like it was like one way basic, like it was static websites, something which you cannot interact with, something which cannot display any rich media like videos or photographs. It was like very simple. You can see what's on the web page, and that's pretty much it. So that was the whole Web 1.0 era. And then we came to the Web 2.0 era, which we can like say we are in right now, in which the internet access became much more global, it went much more wider and reached many more people like throughout the world. Then we have something called apps, which everyone like the mobile phones came along. Then like there are apps in which you can just within your palm of your hands, you can interact with the internet. Within a couple of clicks, you can do anything. And then social media, high quality camera and the data, and 720p, like 1080p, and then 4K videos, and now 8K videos. So like that's the Web 2.0, which increased the quality of access of internet with high-speed communication. For example, probably like you guys are seeing it on a Zoom or something. So this was the whole Web 2.0 concept. And then this is the next like stage of this whole evolution of the web, which is the Web 3.0, in which Web 1.0 and Web 2.0 gave us like access and information, and Web 3.0 will gives us verifiability and the access to everything without having any intermediaries. So that's the whole concept of like with permissionless blockchains like Shardeum. Then we will have decentralized applications which just won't be running by a particular organization in a cloud somewhere. Like we can be sure that like it is distributed and well executed. Then we have NFTs, which are not only just JPEGs, but also which derives its value from its intrinsic, what it represents, and not just what we get to see. And then AI, and then interoperability, and then like users will be able to have more control of their data. Users will be like something of this is very has been a very big issue is in the current Web 2.0 industry. So that's the whole concept of evolution of web and how Web 3.0 aims to play the future in the internet's history. So what changes for developers coming from Web 2.0? I'm sure like most of you here are developers. You must be wondering that, like, I am already a developer. I already build websites and all backend applications. So what changes for me? So this is a very like simplistic overview. Like you can see on one side, this is the Web 2.0 apps in which you have the code and the server in which you can write code and like anything like Java, Python, Go, Rust, and you can deploy your write your application on Node.js and stuff. And you can just deploy it in an AWS server, which is like a centralized server by Amazon or like any of the cloud providers. And that's basically the whole connection. Like you have a front end and a back end, and you connect those two, and you have Web 2.0 dApps. The whole concept of Web 3.0 dApps, on the other hand, is like the front end still remains the same. Like you can still code your decentralized application front end in like popular frameworks like React or like JavaScript. The only thing which changes is the backend part. The backend part, instead of having to rely on a centralized solution like AWS to host it on their server, you are basically giving away your backend to a decentralized compute platform in which instead of having a single server do all the computation for you, you are basically distributing it across a node or like a collection of validators who are doing the work for you. And obviously in a different case, they're charging, instead of having to pay just one person, you have to pay the entire network, and it's being distributed, and the network all handles it for you. With the whole case of gas usage, I'm sure like most of you are already aware, to use any blockchain, you pay a transaction gas fees. So that's how like the whole landscape has changed. Again, like as a front-end developer, nothing changes for you. And as a back-end developer, you are introduced to a couple of languages like Solidity, in which you write your contracts. And those contracts are basically what your backend is. Those contracts, once deployed on the blockchain, will ensure whatever criteria you have specified will be executed without even worrying about like server call, like server outages or those kind of stuff, because a blockchain is always active, a blockchain is always listening, a blockchain just follows what you code in it. So if your smart contract has a function which calls at 12 a.m. tonight that transfer this much amount of token from this address to this address, you can be ensured that once deployed, the smart contract will act like without any other blocker, will definitely, because you have coded that thing, it will definitely send that amount at that particular point itself. So what we are achieving in general sense is basically we are able to automate much part of the like trust. Like instead of having, usually in a Web 2.0 case, you will have to set up a trust when for example in a financial transaction, you will have something like a bank to do that arbitration for you, making sure that one part the money is deducted and the other part the money is sent. But in case of Web 3.0, like all of this is done with the help of automation of your smart contracts, and you don't need to rely on any third party companies or governments or agencies. Yeah, those kind of stuff. So yeah, the features of blockchain, I think I think most of you are again like already aware, but like I just quickly wanted to cover these stuff. Decentralization, like you're not hooked to one AWS or Google Cloud. You can be ensured that at the end of the day, what you want to achieve can be happen, like without even having to worry about your servers getting shut down or like paying tons of fees as monthly server costs. You can, it's just a one step deployment for you. Then immutability, like this is something which is very important. Like every now and then we hear that this bank got hacked and the credit card details got hacked and those kind of stuff. And you can be sure in this case, in the case of a blockchain, that everything is immutable. Like once it's on the network, it cannot be changed, so it cannot be hacked, or you cannot game the system, because the whole system relies on cryptographic verification and it happens automatically. Then trustlessness, you don't need to be dependent upon any third party state that like something will be made for you. Like if you have, like as I mentioned, if you have made a function call at particular point of time, that function call will happen automatically, will get executed. So you don't need to worry and like trust any other third parties. Then transparency, in case of a public blockchain specifically, everything is transparent, all the transactions, all everything that has ever happened and everything that will ever happen will always be transparent, and so you can be ensured that it's an equal level playing field for everyone. And then there's interoperability, so blockchains can talk to each other, like even from other ecosystems. There are developer tooling like Chainlink, which can bring out like all off-chain stuff to on-chain. So you don't need to worry about like how you handle those kind of data, and everything is interoperable in some sort of the other way. So these are the primary features of a blockchain. Then yeah, applications of blockchain, decentralized economy, like you can automate the entire, like to be honest, like an entire country's financial throughput and financial value through blockchains. And then there are smart contracts, which are like code specific law, like if it can be, you can be ensured that anything you have ever written in a smart contract will behave the way you want it to be. Then there are dApps with all kind of applications. You can have decentralized applications. You can build out decentralized finance. Then there is NFT applications in which you can then there's record management platform. For example, if there's a national identity service, for example, everyone wants their identity to be on the chain, so that you can be, whenever it's needed, you can verify on chain without even requiring a third party provider, that everyone has been given a particular address, and just by verifying that address you can check whether the ID is valid or not. So those kind of stuff, record management, record of lands, and those kind of stuff you can bring on chain, and you can build specific applications on the blockchain. And these are like, since those inherit all the features just we discussed in the last slide, those give you they ensure that everything is automated and secure and immutable. So yeah. And then let's discuss, I think I mentioned briefly when I was covering the points initially about the blockchain scalability trilemma. So now we are moving towards the problems and the issues. So what happens is in the industry, we have something called a scalability trilemma, which mentions that there are like three parts to a blockchain. It's a scalability, decentralization, and security. And at any given point of time, it's assumed that a blockchain can only have two of those. If it has scalability and decentralization, it won't have security. If it has security and scalability, it won't have decentralization. So only two of those features can come in live at a time. But that's what has been limiting our public blockchain ecosystem for quite a long time for now. But for example, in case of Ethereum is like highly decentralized and highly secure, but then Ethereum is not scalable. It can only, like, it has only reached around 28, 30 TPS at a maximum point of time. And compared to regulation, regular finance applications, 20, 30 TPS is like not even close to what we need. So that's the whole concept of blockchain scalability trilemma, and that's what we are facing currently in the industry. The issue is that existing blockchains don't scale linearly. So what happens in any of you have already used AWS or something like that, you already know that if you deploy your application on AWS, your application is linearly scalable. So if there's a lot of traffic coming in, then your application is able to, like, AWS or gives you more compute power, more CPU power, more RAM, so that more traffic can be handled. And then when your users leave your application, or like it's a night time, then the server automatically lowers its requirements, and again the computation is adjusted according to the necessary requirements. But in case of blockchains, that didn't happen till now. So which means that either it gets too expensive, or it lacks decentralization, or it becomes easily vulnerable to the attacks because of the the whole scalability trilemma thing. So that's what we at Shardeum are trying to achieve. It's the whole concept of linear scalability. We are bringing the entire concept of scalability, in which you get in a Web2 kind of a server like AWS onto a decentralized public blockchain platform, which is Shardeum, in which with every new addition of nodes, you can like your TPS is also increasing. So what happens is like in Shardeum, there are like two groups of validators. One is active and one is standby. And whenever the network realizes that there's a lot of network load and an auto convey congestion, the network automatically adjusts itself and brings in more from the standby to the active validator pool, and the TPS is increased. So that's how we are planning to like solve the scalability trilemma by, even though we are being decentralized, and anyone can join in as a validator, like the network is able to scale also without sacrificing security. So that's the whole concept of what we are doing at right now at Shardeum. So yeah, Shardeum is an EVM compatible layer 1 dynamically sharded blockchain. So how now we initially discussed that it's a linearly scalable platform, but the entire concept of how we are able to achieve that is through a process called dynamic state sharding. The whole concept is we're going to discuss about it in a next slide about what is sharding in general and what is state sharding and what is the difference between a static like state sharding and dynamic state sharding. But yeah, with that, let's go to the next point. Is the combination of proof of stake and proof of quorum. These are two consensus mechanisms which we use at Shardeum. You can definitely read more about it. I'm sure most of you have already heard about proof of stake, and like you can also read about proof of quorum. And consensus is done on a transaction level and not on a block level. So traditionally, consensus in all other traditional blockchains like Ethereum and all the Ethereum major ones are done on a block level transaction consensus. But in Shardeum, it's done on a transaction level. And like in our next slides, we will get more clear why that is done. So yeah, comparing to the point of sharded versus an unsharded blockchain. So in traditional blockchain like Ethereum, every node has the entire data of the entire blockchain, which becomes impractical as the network size grows. So if there are 100,000 nodes in the network, the 100,000 nodes has the state of almost the entire network of the blockchain ever since the Genesis block in case of a full node. And that becomes like, you can understand that will, and a blockchain is always running. There are transactions happening every second. It's getting added to the already existing big pile of data. So what happens is like the size keeps on increasing and the nodes keep on getting heavier and heavier, and they're not able to compete in the long run. So sharding is a way to partition the blockchain into smaller, like more manageable piece called shards. It's each shard is nothing but just a group of validator, and you can imagine that as a subset of the entire pool of validator in the network. Um, in a sharded blockchain, on the other hand, each node is only manageable for only a subset of the shards. So instead of in a traditional network in which all the nodes has data of all the state, like in the entire state, in a sharded blockchain, you only give each of the shards a little piece of chunk of the entire network. So, and all of those chunks together combined still form the entire state network. But instead of giving everyone the whole piece, you're just giving a small piece to each of those shards. And as you can imagine, that like already makes it like 10 times, 100 times more efficient and a better way of doing things compared to an unsharded blockchain. And sharding concept is not practically new in computer science. Like we have been using the concept of sharding in our databases for a long time now, but this is Shardeum is implementing those already battle tested proven concept into the blockchain ecosystem. And yeah, like, and if we want to simplify this even further, let's imagine that in a metro station, you're entering metro station and you're swiping your metro card. Instead of like in an unsharded blockchain, there is only one, like there's only one gate in which a person swipes a card and enters the metro station. And there's a, like, you can understand soon there will be a long line to get into that one gate. And in the case of a sharded blockchain, instead of having one gate, you have 15 different gates. So at any given point of time, there are 15 people entering the metro station parallelly, thus like parallel processing becomes possible in a blockchain network like Shardeum. So that's the whole sharded versus unsharded concept. And yeah, like now that we understand what the difference between a sharded and unsharded blockchain, like let's visualize a bit on how like the dynamic state shard happens. So you can imagine, yeah, this is the entire like Shardeum blockchain network, and the entire blockchain network is like what in this example divided into 4 different shards. Obviously, in a real world example, it's not the same case. There are multiple other shards. So you can understand. So there are, and in each shard, we are assuming that there are only 4 nodes. So 4 nodes in shard 1, 2, 3, and 4. And each of those shard are able to process transactions like individually. So as I mentioned, like this is like comparing to the metro station example, this is one gate, this is one gate, this is one gate, this is one gate. Now, traditionally, entire thing only behaved as one gate, but since this is a sharded blockchain, each of those gates are able to process their own transactions. And in this example, instead of having one transaction at a time, like we are having 4 different transactions at the same time. And now if you just scale it in a bigger status, like which the Shardeum blockchain is, like you will get the idea of how the scalability is achieved. Sharding also improves the security of the blockchain because in case of Shardeum, like how the shards are formed is not controlled. The network with every new transaction, an automated access list is produced. This access list basically tells the network that where to look into, which are the addresses or contract addresses or wallet addresses that transaction interacts with, and the network automatically assigns, looks into the entire network and brings in the nodes responsible for that data and forms a shard. So it's a completely automated process that no one can game the system. So that's why the security is improved, because you won't ever know, a hacker will never be able to identify where the data lives, and they won't be able to form a shard manually. So that gives us a layer of security, and it also reduces the amount of computational power required. As you can imagine, like now that the nodes don't have to hold the entire network state, it only holds parts of it. So Shardeum validators have very, very low hardware requirements compared to like other blockchain networks. And this is the more efficient way of doing things if we want more validators into the network, and more validators means more security and decentralization. So yeah, that's the whole concept. Then coming to the features of Shardeum, there are like mainly 4 different features. We already compared dynamic state sharding, and now we are now going to discuss the other 3. Atomic composability. So now I'm sure like some of you who have like learned about Ethereum and how Ethereum works and how general blockchains work, the entire concept is that like we get since the entire network of nodes has the entire state of the network, they are able to make sure that the transactions are going through and everyone has all the data. And in case of a sharded blockchain, that becomes a challenge, because if one shard wants to interact with other shard, how will that interaction happen? So that is one of the features of Shardeum, in which we have full atomic composability. So no matter in which shard your data lives, or which node your data lives, like a smart contract developer like you won't have to worry. The network will automatically handle all of those stuff behind the scenes for you. So you get complete atomic composability. So you don't need to worry about how the data is sharded and all. So, and then we have the feature of auto scaling. I already discussed that there are 2 groups of validators, active and standby. And if there are 500 active validators and suddenly the network needs more number of TPS, then the network will grow from 500 to 800 validators. And again, like when the TPS is again it's not that much needed, like the TPS will again be reduced. And then Shardeum is EVM based Ethereum virtual machine. It's the same which the most popular blockchain network in the world, Ethereum, currently uses. So like any contract or any smart contract which you build for Ethereum will also run on Shardeum without a single line of change of code. So that's one of the biggest features we wanted to have. And all the existing EVM level tooling like Hard Hat and like the blockchain explorers are compatible with Shardeum. So yeah, that's basically all the features about Shardeum is. And yeah, this is the link for the Shardeum docs. Definitely check it out for ETH Riyadh, the hackathon and the bootcamp. I'm very excited to see what you guys build on top of Shardeum. And feel free to reach out to me on Twitter or like in the Telegram group, which I think organizers have created. And I will be happy to answer any queries. Thanks a lot for having me, and see you building on top of Shardeum. Bye-bye.
All right. Thank you so much, Sandipan. That was our final session for day one of the ETH Riyadh 2023 Meta Web3 Builder Competition. I want to give a thanks again to the Community Organizing Committee with Tharwat Technology, Studio 1727, Chain IDE, Coffee with Crypto, Mask Network. And I also want to thank our sponsors, Web3 Port and Moon Capital. Today we had some amazing talks from Wei Tsai, Abdu, Jeffrey Hu, Kyle Peacock, Joshua, and Sandipan. I hope you all enjoyed day one of our workshop for this, and we will be live again tomorrow for some more sessions. Again, we will be hosting a daily workshop every day through the 28th this week. So thank you all. We hope to see you tomorrow. Have a wonderful day.